here's an example of a top-heavy fraction, 7 over 3. So 7 is bigger than 3, so this is bigger on the top, and this is smaller. So if in doubt, go back to an example that you understand, like basic numbers like this. So we could write 7 over 3 is 2, meaning that you can get 2 wholes out of this division, and then a remainder of 1, which is fine, but it's not very nice algebraically because remainder isn't an algebraic structure. So it would be a bit better to write what that actually means. 7 over 3 is 2, and as well as 2, we've still got 1/3. So when we write it like this is called the quotient, and up here you have the remainder, and notice that the remainder is still on top of that thing that you were dividing by at the beginning. So this all makes sense. We could also multiply everything by 3, so that would say 7 is 2 times 3 plus 1. That's a nice way of writing it. And yeah, I think the structure is more obvious when you look at actual numbers, but what we're going to look at now is the same idea but with algebra instead of numbers. So see if I can create a bit of room here and then show you the same idea but with algebra. So for example, say we've got x cubed plus x squared plus 2x minus 1. That's going to be my big thing. And then on the bottom something smaller, so smaller than a cubic. It's just the highest term we're looking at. So the smaller than a cubic is, for example, a quadratic. So x squared minus 1. So there's my big heavy top, and there's my smaller denominator at the bottom. And I'm just going to tell you how, obviously it's not like 7 over 3, you can't just look at that and go, oh, well, that's obviously just x plus 1. But it is. So I'm just going to tell you how this works out. X cubed plus x squared plus 2x minus 1, big heavy top, divided by x squared minus 1 on the bottom, is actually equal to x plus 1. X plus 1 is how many x squared minus 1s there are in that cubic, in the same way that 2 is how many threes there are in 7. So that's the quotient. And then the remainder, well, the remainder is something that's going to be less than this quadratic at the bottom, in the same way that the remainder was something less than 3. You wouldn't have when you're doing 7 divided by 3, you wouldn't have a remainder of 4/3, because then 4 is still bigger than 3. So the remainder is going to be smaller than this denominator, which is a quadratic. So the remainder might be something to do with x, or it might just be a number. In this case, it happens to come out as something to do with x. So this is the quotient, x plus 1, and the quotient is how many x squared minus 1s are in x cubed plus x squared plus 2x minus 1. And then this here is the remainder, which is not a number anymore because we're not dealing with numbers, but it's something smaller than that quadratic. We could do what I did, that final step at the bottom with the 7. Instead of writing 7/3 is 2 plus 1/3. I can times everything by 3, make it look a bit nicer. I can do the same thing here. I can times everything by x squared minus 1 and get this cubic is equal to this quotient. That makes it more obvious what's going on there, that the x plus 1, the quotient, is how much x squared minus 1 there is in that cubic, but it didn't quite work out perfectly. It didn't factorise because there's a remainder of 3x. So really, we're doing the same as we would do with numbers, but this time with functions, and obviously you need to know how to get this quotient and remainder. So let's do that now. So the process of long division is basically divide, multiply, subtract. Divide, multiply, subtract. Hence being sponsored by Doc Martin Shoes to help you remember. So you've got your fraction, and you've got your top, which is heavy, and your bottom, which is less heavy, smaller. So your top is heavier, and your bottom is smaller. And you're going to set it up in the bus stop way that you might have done at school. So here is the bottom, the smaller bit, and here is the heavy top in here. And you're going to first of all divide, then multiply, then subtract, like this. So we go over here, we do dividing, and you're just dividing the highest degree terms, that's all. So just the highest degree, when you divide, highest degree terms only. do an example, you see what I mean. So you're going to divide, then you're going to multiply over here on this side, and then you're going to subtract inside. And then that is one stage done. And then you just keep, literally repeat. So you're going to divide over here, then you're going to multiply over here, and then you're going to subtract like that, and then done. And then you're going to divide, and then you're going to multiply, and then you're going to subtract. Woo, can't squash it in. Okay, let's have a go, see what I mean. Really practice, but that's the general idea. Divide, multiply, subtract, divide, multiply, subtract. Okay, let's have a go. Okay, let's try this example that I showed you in the previous section, but I'm going to show you how I actually got it. So we're going to start by dividing the highest term. Then we're going to come on the left, highest term on the top and the highest term on the bottom. Then we're going to come on the left and multiply out, and then we're going to come into the middle and subtract, and then we're going to keep repeating that process. So let's try. X squared minus 1 into x cubed plus x squared plus 2x minus 1. There's lots of numbers here, so keeping it as neat as possible is really important. So we start by dividing. We're dividing the highest term of the top, which is x cubed, divided by the highest term of the bottom, which is x squared. The thing we're dividing by, x squared. So dividing highest term by highest term gives us x. Now we multiply out, and we're multiplying the thing that we just got by dividing, multiplied by the divisor, x squared minus 1. And be really careful when you're expanding this out, keep everything all lined up. So this column's for cubes, this is for x squareds, this is for linear, this is for number, keep everything lined up. So now I've got x cubed, I'm going to do minus x, and I'm going to put it here underneath the right column so that everything subtracts nicely. Okay, done dividing, done multiplying, now subtracting. X cubed minus x cubed is nothing. That's good. If you don't get nothing there, then you've gone wrong. X cubed minus x cubed is nothing. X squared minus no x squared is x squared. 2x minus minus, be really careful with minus minus. 2x minus minus x is plus 3x. That's often where people go wrong. And then minus 1 minus nothing is minus 1. So there we go, divide, multiply, subtract. Let's go again. Divide. The biggest thing we've got now is x squared. We're dividing by the biggest thing of the thing we're dividing by, which is x squared. We're always dividing by the same thing. We're dividing by x squared minus 1. So the biggest term there is x squared. So this is 1. Dividing, multiplying. 1 lot of x squared minus 1 is x squared, keeping everything lined up nicely, minus 1. Subtract. X squared minus x squared is nothing. Good, that's a good sign. Should be nothing. 3x minus nothing is 3x. And being very careful with minus signs now. Minus 1, minus minus 1, minus 1 plus 1, 0. That's it. Okay, this is the end because the next step would be dividing, but 3x is already smaller than x squared. So I can stop now because I've reached my remainder. So what have I actually got here? All the stuff that popped out on the right hand side, this stuff, this is your quotient. So your quotient is x plus 1, all the things that came from the dividing, and that's what we saw here. That's the quotient. And then the thing at the bottom that gets smaller than the denominator, that's your remainder, and your remainder is what we saw up here on top, the 3x. Right, hopefully you followed that. Divide, multiply, subtract, divide, multiply, subtract. So here's one for you to have a go at. It's a typical exam question. Show that x cubed plus 3x squared plus 2x plus x plus 2 over x plus 1 can be written in the form ax squared plus bx plus c plus d over x plus 1, where you're supposed to find a, b, c and d. So all it's doing is asking you to find the quotient and the remainder. Here's the quotient. That's the bit that comes out, and there's the remainder there. So the remainder in this case will be a number because that's the only thing smaller than a linear x plus 1. So that's going to be a number, that d. So pause the video and have a go at this yourself, because until you've done it yourself, you can't be confident that you've learned the method. Remember, what you're doing is you are dividing on the right, then you are multiplying out, and then you are subtracting, and then you're repeating that process, being careful with minus signs. Okay, pause video, have a go, and then on pause and I'll go through the solution. Okay, let's have a go, see how you got on. Divide. X cubed, highest thing divided by highest thing. Multiply. Subtract. Divide. Multiply. Subtract. Divide. Multiply. Sorry. Subtract. Oh, careful with minus signs. That's going to be 0, but then 2 minus minus 1 is 3. Okay, stop. So I get, as my answer, okay, my quotient is x squared plus 2x minus 1. Let's put that there a minute. And let's see what I got. So this is what I got. X cubed plus 3x squared plus x plus 2 over x plus 1 is x squared plus 2x minus 1. That's my quotient that came out down the right hand side, all those little bits that came out down there. That's the quotient. And then the remainder that I got is 3 over x plus 1 still. Hopefully you got the same as me.